Now we're going to talk about measures of position and outliers. These are pretty important, especially the z-score, because it tells you how to assess where something falls on that normal curve that we talked about in the last set of videos. So let's get into it. Z-scores represent the distance that a data is relative to the mean in terms of standard deviations. This is helpful when comparing two different means and values to one another. What the z-score does is it kind of creates like a ratio among, it's not necessarily a ratio, but kind of, it sets a standard for figuring out how many standard deviations away from the mean something is. And that's very important because we want to know if it falls in that 95% of data, or if it falls outside of that at 97%, or something even more drastic than that. So we've got those formulas. At the end of the 2014 series, the Los Angeles Angels led the American League with 773 runs scored, while the Rockies led the National League with 755 scored. The National League, that is. It appears that the Angels are better run producing team. However, this comparison is unfair because the two teams play in different leagues. The Angels play in the American League, where designated hitters bat for the pitchers, whereas the Rockies play where the pitchers must bat. The two teams, to compare the two teams' scores, we can do this using a z-score and looking at the data from the National League and the American League. So what I'm going to do, I'll pull this up.
I can learn to understand.
No, you can't. So what we can do is we've got a mean of 6774, and so this is the American League. So let me write this down. We've got the mean is 677.4, and the standard deviation is 51.7. And then the Rockies scored 755 runs. And then we've got 640 and 55.9. This is the National League. Okay, so now we can compare them. So the X represents the number of runs scored. So 773 for the Angels. So we've got, this is the Angels. 773 minus 677.4 divided by 51.7. Okay. So there's that comparison, and then we've got the other one, which is 755 minus 640 divided by 55.9, and this is for the Rockies. So if we go and do that math, which we're going to do, we have 773 minus 677. Oops. That's not 773. Minus 677.4 divided by 51.7. And we get 1.85. Okay. I rounded to two decimal places. This is the one time when you're going to do two decimal places. This is a z-score. That does not look like Rockies. Okay. Then we have 755 minus 640 divided by 55.9. 2.415. Now, how you read this, if you have a number line, here's the 0, 0 is the mean. The Angels are at 1.85. Here's two standard deviations. And then all the way over here are the Rockies. They're at 2.42. So in comparison, the one that's farther from 0 is the more abnormal one because it's outside of 2 standard deviations. Remember, the 2 standard deviations, that's 95% of the data. That's normal to fix something in there. But if you get something outside of that, we call it abnormal, and that would be what the Rockies score batting percent was for the home runs. And so when you do this, that's really all you're doing. You're just plugging them in and doing them. So in class, I would have you do this. I want you guys to go ahead and try this, and I will post it in the next video. Thank you, guys.